shapes of box and whisker plots. So shapes is another way to kind of describe the distribution or say what's going on here. And if you take a look at our 3 box plots, we have a skewed left, a symmetric, and a skewed right. And the way I typically tell these is you want to look for the tail. Okay, and if you think about an animal, the tail is that long thing that sticks out the back. So if I'm looking at this box and whisker plot, do you notice that kind of has a longer whisker or a longer tail on the left? Therefore, it is skewed left. It's wherever the tail is. So the left whisker is longer than the right whisker. Most of the data are on the right side of the plot. So I don't really ignore that. I just kind of look at the tail. So it's telling you that the data is more spread out here on the left if it's skewed left. Symmetric is everything is kind of evenly spaced. You know, your 25, 20, the numbers are evenly spread out. The whiskers are about the same length. They're symmetric. Skewed right, you kind of have a tail over here. Okay, so the right whisker is longer than the left whisker. So the data over here on the right side is further spread apart. Therefore, it is skewed right. Example 5, comparing box and whisker plots. The double box and whisker plot represents the length in yards of field goals made by 2 football kickers. So we have kicker A is the blue box and kicker B is the red box. And then the number line, so if you travel up to find your numbers, is true for both box plots. Now it says part A, identify the shape of each distribution. So I'm going to start with the blue one, which is kicker A. And to me, kicker A looks like he kind of has a tail over here on the right. So because he has a tail on the right or longer on the right, we're going to call him skewed right. Now, kicker B, which is our red one, look about the same. I mean, this is a little shorter than this one, but the tails look about the same. He looks kind of, he doesn't have to be exact, but to me, he looks pretty symmetric. Part B, which links are more spread out? Explain. Well, for this one, you know, a box plot shows the variation or the spread of the data. And if you look at kicker A, do you notice that his box plot is a whole lot longer than the box plot for kicker B? You could figure out that for kicker A, this is at 24. This is at 36. The range here is about 11, 12, versus this is 22 to 31. The difference there is 9. But which lengths are more spread out? Ultimately, I'm going to say kicker A. Explain. I'm just going to say box plot is longer.